Hello, everybody. Oh, my iPad is dead. Okay. Welcome, everyone. So today I want to mostly just go over, continue working on those types of word problems that we did yesterday, and hopefully try to do a few of the uh, questions from the homework that I posted them a little bit later, but even if you haven't had a chance to go over them, I'd like to start a few of them in class today. And then one really good thing you can do is do them again for homework on your own. Maybe do them like on Saturday or something. You're not going to remember exactly the numbers of everything that we did today in class, but you'll have your notes. But it's really, really good practice to try to just see if you remember how to set it up the way that we thought about it in class. Um, so let me see here. Notability. Okay, so yeah, let me get some questions now. And please message everyone so that people see which questions are being asked. Which ones do you guys want to go? Which ones in particular do you want to see today? So could you think of 8.1, 8.143 about the average? Well, and let me share the screen here. I'll have these all up. Okay, awesome. So okay, uh, looks like basically a lot of them will be. All right, so 8.1, 55, 55, and 73, and 79. I have 8.2, 8.2 number 73, 8.1, 31. 73, 79, 8.2. Okay, 8.1, 65. 8.179, we got that. 8.380. Oh, that's a fun one. Okay. That one maybe we'll talk about on Monday. We'll see. I don't think we'll get a chance to do all of these. 8.380, 8.167. Okay. 31, 65, 71, 71, 77. All right. So basically a lot of questions from 8.1. So okay, let's go through 8.1, and we'll try to do as many of these as we can. And I would like to do a few today from 8.3. And I think the questions on 8.1 is just kind of with substitution, elimination. Hopefully it won't be too bad. So let me just take a look here. So 8.1, number 31. Okay, let's just look at this one. 8.131. I'm not really going to ask you to solve a system graphically, like doing it on a graph. I just expect you to know that concept, that it's possible to do that. So 8.131. This one asks for the system y equals -1/4 x plus 1 and 2y equals x minus 4. Okay, just by looking at it, doing, oh, is that the wrong, were some of these not required? I don't exactly remember which ones were on the assignment. Let me see here. So hit yes if you still want to see this one worked out. If anybody. Okay, so I'll just kind of do this one. I won't finish it all the way, but one approach you can take here is, because it's not written in standard form, it looks like the second one is almost like slope-intercept form. I would just do substitution here, move this over and write y equals x over 2 minus 2, divide everything by 2. And it says in prompt here to do it by graphing, which is a good thing to practice. So you would draw the graph and solve it that way. But here, if you didn't do it by graphing, you could use substitution. But is it clear that there's going to be at least one solution? Who can tell me why we're guaranteed to have at least one solution? Or actually exactly one solution? How do we know? Just by looking at this pair of equations, how do we know that it's going to be one solution? Yes, sir. Yeah, exactly. They aren't factors of themselves, and they also have different slopes. So anytime you have two lines that have a different slope, they got to intersect somewhere. All right. Let's move on to 43. Yes. This section, translating, is a really good one for setting things up. So in 2012, and if you have your book open, it's helpful, you can kind of read along. So this is number 43. So this is 8.143. Make this smaller. So 8.143, it says, in 2012, an average email you sent or received 115 emails each day. So 115 emails. So 2012, the average user sent 115 emails a day. The number of emails received, so they sent or received. $115 emails a day. The number received, so number received is one more than twice the number sent. The question is, how many were sent? And how many received? Okay, so anyone have any thoughts? Anyone want to volunteer their idea? How do we, first remember our steps, define our variables, write some simple equation, and then solve. Here we don't even need to solve, we just need to set it up, so we don't need to worry about the solving. So, yeah, what was it?
Wait, me or Archer in the chat?
Go ahead, Lily, yeah.
Okay, so I did n equals the number of sent.
Okay, sure.
And then I kind of did a little differently, and I did 2n plus 1 is the number received, which I know isn't like how we normally do it, but it gets you the same answer.
Oh, that's fine, yeah. So let's just do R is a number of received. Received I before E except after C, is that right? Yeah. My bad here, guys, sorry. Do you guys also struggle with this? Okay. Okay, so Lily, you said that if you translate that sentence, we focus on the word is. So we say that received is equal to 1 plus 2n. And then what did you do after this?
So I just set it up like n plus 2n plus 1 equals 15, which it would just be n plus r equals 115.
Awesome, yeah, exactly. So you just jumped one step, but that's perfect. M plus r is equal to 115, and you can, if you see it right away, you don't like, you can just plug it in. That's totally fine. These are really similar to the ones that we did with, like, I tell you the perimeter, total perimeter, and I tell you the width is like something related to the width, so something related to the length, and then you can just right away plug it in. So that was an example actually of two equations and two unknowns. So we plug it in, 1 plus 2n equals 115. And then I'll show you guys something kind of cool. I think some of you might know this. When you add the two n's, you get 3n equals 114. Okay. We don't need to solve this because it just says to set it up. So we already did the setup. This is totally fine. This would be the answer. This would be the sufficient answer. And you would solve by either elimination or read the substitution. Does anyone know this trick? do you guys know that if, without doing the actual arithmetic, can you tell me that if 114 is divisible by 3? Does anyone know? And if it is, well, what is it?
It's 38.
It's really awesome. Could you have can you have figured out, do you know how you can check if it's divisible by 3 without actually dividing it?
I don't remember, but I know I learned the trick.
Yeah, there's a neat little trick. Anybody know it? So it's really cool, and I'll encourage you to think about why it's true. I'm not going to explain why it's true, but over the weekend, please think about it. So what you do is you just add the digits together, and if the digits are divisible by 6, so you add these digits together, so you get 1 plus 1 plus 4 equals 6, and that is divisible by 3. So it works. Let's try another one. How about I don't know, does anyone want to pick a number, like 3 numbers that add up to something that's divisible by 3? Anyone want to volunteer a number? 261. Yeah, that works. So 261, if you add the digits together, they add up to 9. 2 plus 6 plus 1 equals 9. So this should be divisible by 3. What is 261 divided by 3? Can anyone do that one? What's a good, nice multiple of 3 next to 261? There's one nice one for sure. That's really close, pretty close to 261. You can round to the in the tens place, like. Anyone know? 261 over 3. So 240 is close to 261, and we know that 240 divided by 3 is 80. So then we get 87, because there's 21 left over. So this does work. So 87. If you've ever, have any of you heard of the idea, the shortcut to like test for divisibility of casting out by 9s? So yeah, I encourage you to investigate this. Check if a number is a multiple of 3. So this is a little homework investigation, and I'm really curious if anybody comes up with a reason why it's true. And you know, math is about exploring. It's not just about like, okay, here's how to do a problem. Okay, do these exercises, memorize this strategy. It's also about just like, okay, I see an interesting observation. I don't know why it's true, and I'm just gonna mess around and see if I could figure out why it's true. And it's okay if you don't. I think the fun thing is trying to come up with a reason why it should be true. So investigation. So why is the following true? If a number n is divisible by 3, then, and also the other way, so a number is divisible by 3 if and only if the sum of the digits is divisible by 3. Okay. So how many of you are curious why this is true? It's kind of unexpected, maybe. So if you're curious, I encourage you to take a look. All right, let's continue to number, what do we just do, 43? Oh, did that answer the question? One student asked about like, I took an average and I didn't quite get the right answer. Does it make sense now like the average thing is a little bit misleading. It's just like an average user. So it's not really about an average of like sent mail or received mail. It's just like yeah, you only have to set it up. Yeah. Okay. Let's go to 8.143, 8.1, 55. Oh, I like this one. This one is write a problem that has a system of two equations, and you want the answer that the bucks. This is kind of like a Jeopardy question. Like they give you the answer, and you got to come up with the question. So the answer is the bucks. The bucks made 6 3-pointers. And 31 2-point baskets. Okay. Can anyone give me the system of equations that would have this as a solution? There's one really simple system that you can write down. And of course, first you need to tell me like what would be a good set of variables. So we're going to kind of work in reverse here. We want to get this as our answer. What would be the system, or what would be like the question that you could ask that would give you this as an answer? And what information do you need to kind of lead with? Anybody have any ideas? Message me also if you're totally stuck, you're not sure, where to even start. Nice. Anaya has a really good idea. Anaya, do you want to share your idea for the variables?
Yeah, can you hear me?
Yeah, I can hear you. Yeah.
Okay. So the variables would be x would be 3-pointers and y would be 2-pointers.
Excellent. And I'm just gonna modify a little bit just so that it's like even more crystal clear. Number of 3-pointers, and then y would be number of 2-pointers. That's perfect. Okay. So Anaya, where would you go from here? What kind of, from reading what the answer is, what equation could we write down that would be like a really simple equation with x and y?
Would it be the ones that have like the y equals something something, and then on the bottom it would also be like y equals something something? But I don't know what it would be. But it would be that.
Not exactly. It could be something like that. You definitely could write it that way. But maybe think about the one. This is actually really similar to the one with the Mesa College credits.
Is
Yeah,
it just?
Don't know how to describe it.
Is it just x plus y equals 37?
Yeah. And does that make sense? Like, there's 37 total. Like, it's a little weird, this question. It's like we're given the answer, 6 of these and 31 of these. But before we're given the answer, the question would have been, we don't know how many of each, but we know for the total that there's 37. It's kind of like the Mesa question where I said like they took 20 classes. So this would be x plus y is 37. Or if it was in a word problem, it would be they made 37 shots total, and we don't know how many of each. Okay, and then Allison, any ideas? I know you mentioned you were a little bit stuck, but any thoughts on what you can do for the next equation?
No, I feel like I'm just lost.
Okay, okay. So you remember the one with the Mesa? You remember the Mesocratic one?
Yeah.
You remember like the first equation was like total credits, and then the second equation, sorry, the first equation was total classes, like they took 20 classes total. And the second equation, do you remember what like the quantity was?
Yeah, you just had, it was like something, it was like a number X plus another number Y equals another number.
Yes. And what do those numbers represent?
The number of like baskets or like not, well, this case baskets, but the other one was like the credits.
Exactly. So the baskets here in this case is more like the classes. But instead of credits, what's analogous to like total number of credits? If you can take 3 credit courses and 4 credit courses, here you can get 2 points and 3 points. So what equation do we kind of want to write down? Instead of focusing on total credits, we can focus on total
Points.
points. So if you make a x 3-pointers, right? How many points do you get for that? Like what could you write? What number do you write in front of the x?
3. Oh wait,
Yes.
no, it would be, yeah, right? 3 or
Yeah.
2.
Well, 3 because it's a 3-pointer. So like if you made 5 3-pointers, you're going to get 15 points.
Okay.
3x. And then what do we do with the y?
2Y.
2y. Okay, now we have to go back to like the answer. How many total points are made in this situation?
37.
37 is it? Oh no, that's the number of baskets. But what's their actual score? So you have to add things up. So and you have to multiply and then add.
Okay, wait, let me do it real quick.
So yeah. Nice little. It's something. What is that something?
I got, just a second. I got 80.
Yes, I think I like 80. Do you guys hit yes if you like 80? Cool. Awesome. So you just kind of use the information that's given to figure out the total number of points. Okay. This is a really nice exercise. Oh, why 80? Alison, do you want to explain how you got 80?
Because there's 6 3-point baskets and 31 2-points, so you just multiply 6 by 3 and then 31 by 2 to get the number of points.
Sweet. Very good. So we use the information there to set up a two unknown problem, and we know that it's going to have this solution. Okay. I really like when you're forced to kind of think through a problem backwards from the answer. It really, I think, increases your understanding of like the setup and stuff like that. Okay. Are there any questions on this problem? You can message me privately or just hit the space bar. All right, Allison, thank you for helping out there, and Anaya as well. You guys did really well. Okay, so let's go to the next question, which is, we did 55. Let's go to 65. Oh, by the way, I was going to ask about, it's a bit of off topic. Oh, what is the final answer, I think, is just this pair of equations. This is the final answer. Let me see if that's actually what it's asking for. Yeah, this is like writing the problem. Maybe that would be the system of equations. Maybe you can say, okay, the Bucks made 37 baskets and scored 80 points. How many of each type of basket would they solve? Nice, Archery, I think you're right. It's better to turn it into a word problem. Okay. By the way, just like so, this last thing, this last problem, a little bit off topic, but how many of you have seen that movie that came out on Netflix recently, A Social Dilemma? Nice, Maddie. Nice, yes. Yeah, definitely. I did recommend some of my like nieces to watch it as well. Yeah, I'm sure you might have heard it from your relatives. Archer, nice. That's good. Games reading is good also. But this is a documentary. Maddie, can I ask what did you think about it? Nice. Yeah, I recommend for everyone. Yeah, I had the same exact feeling. So those of you who haven't heard of it or haven't seen it yet, it's like a hour and a half documentary, um, and it's interviews from these guys who used to work at all the big tech companies like Facebook, Google, Pinterest, um, and basically how it's designed. The services are designed to uh, capture our attention, like all these things, even the phone itself, not necessarily like the Facebook app, which is really like designed for that, but even things on the phone like constant notifications, um, even like do you guys know that feature that was introduced like a few iterations ago on the iPhone, and I think Android had it for a while, that when you like lift up your phone, the screen without even touching anything, just when it senses a lift up, the screen will turn on. Have you guys seen that feature? Or you guys all probably have that. Yeah, when you just like when you lift it up or like glance at it, it'll turn on without you touching. You used to have to touch a button to do that. But most phones now you just have to like lift it up and look at it. Um, uh, so anyhow, there's all these different like little usability features that you think like you might say, oh, that saves me like a button press, so I don't need to actually look at it. But there's another way of looking at all these things where what's really happening is the phone is constantly trying to take your attention and trying to get you to open it up and check something. People, especially, I think all of us have trouble with some level, at some level, with addiction and kind of procrastination and willpower, and these sort of notifications and distractions make it, I think, really difficult um, to stay focused and grow in other areas. Like uh, after this movie, I started keeping track of my screen time, and I saw like my screen time because on iPhone it lets you like see how many hours per day you're looking at your phone, and mine was something like ridiculous, like 5.5 hours. So I've been trying to cut it down to like 3 hours max per day. Um, and there's all these interesting strategies. Like they don't recommend to. I don't know if any of you have used this feature of uh, what do you call it? Like locking an app after a certain amount of time. Do any of you guys do that?
I did that and it like didn't work.
It doesn't. It's a terrible idea, and I didn't know why. I did it for YouTube. Do you have anyone have any thoughts why it doesn't work?
Because I just clicked the thing that says like do it again for another 15 minutes, like
Yes.
use the app for another 15 minutes, and I keep clicking it.
Right. Yeah, I had the same thing. So I didn't know why this happened. I kept doing the same thing. I was like, okay, I put the restriction, but then I just kept like going through it. And it turns out that it's like something in your psychology. It just made it worse. It's the same thing with like slot machines. They say that doing this repetitive action, you get a reward. And so you start training yourself to hit that button of like extend me for another 15 minutes, and then you can relax and have another 15 minutes of the uh, YouTube or whatever you're restricting. So it's better to not do that and just kind of keep track of your screen time and set a goal and like maybe give yourself a reward if you are below a certain screen time. And I also, if you watch the movie, it's really scary, and seeing your screen time made me realize, wait a second, I'm spending like most of my life just like staring at my phone, and I'm a bit older than you guys, so sound like back in my day, but I remember back in the day they used to think TV was really bad, which now I don't even have the attention to watch like full TV shows. So you could do other things like read a book, just be more present. I think it's overall a lot healthier. And I have a feeling, this is my theory, that in a few years, it'll be a lot like cigarettes. Like back in the day, people, the cigarette industry or whatever wasn't very regulated. There were no warnings on cigarettes and there was not as many regulations on it. I think in the future, we'll see more stuff about how harmful overuse of these technologies can be. So, okay, so that's my little spiel. And just this question just reminded me of it because I also like realized that I'm pretty addicted to email. And so I really kind of stopped, if somebody really needs to reach you, they'll figure out a way to reach you. Like, you don't be so obsessed with checking your email. Like I used to like to get to inbox 0 all the time, which is just a huge waste of time. So, and if you think about it, doing 115 things a day, do something productive with that time. Okay, so that's my little spiel. Do you guys have any? I know Maddie had some similar ideas. Yeah, Archer. Yeah, if you don't have any friends, I don't have too many friends, so luckily my phone's not blowing up or anything. So, but yeah, focus on connecting. I think that's the other thing that makes it so difficult to get out of your phone is that we have a need to like have connections and be connected to our friends and family. So that definitely amplifies that power that we have to connect with people, and that can be pretty overwhelming. But yeah, living like a hermit could definitely help. Bring some math books and go live in the woods. That's one solution. Okay. So let's continue. And I recommend that movie. If you haven't seen it, I strongly recommend checking it out. And also during the class, what I recommend as much as possible, I know you have to use a calculator sometimes maybe, but just turn off the phone, turn off notifications if you can, and try to stay focused on the lesson and take notes. That's a really good thing to do. Okay, 8155, number 73. Solve exercise 44 graphically. So this is just kind of with a system of equations. So I'm gonna skip that one. Which one did we do? 67. Okay, let's try 67. Find the solution of the following systems is 4, -5. So we're given a solution. For -5. So that means x is 4, y is -5. Find a and b. So we have ax minus 6y is equal to 13, and x minus by is equal to -8. Okay. Anyone have any quick ideas? Let's try to go through this one pretty quickly. So how do we find a and b? And we're given the solution.
Plug in the x and y.
Awesome, Kanjit. Yes, just plug in x and y. If you plug it into the first equation, you can find what a is. You'll get 4a minus 6 times -5 is going to be plus 30 equals, I'm not liking this. Did I make a mistake here?
It gives you like -4.25 and like another something point something.
Okay, so it's like some weird fractions?
Yeah.
Okay, awesome. Yeah, so it's weird numbers, but you can have coefficients in a linear system that are fractions. By the way, we haven't done questions like this, but if you ever find fractions in your linear system, don't panic. you can always clear fractions by multiplying by the least common, least common multiple of everything. So you can always get rid of a fraction just by making all the other coefficients bigger, and then you can solve it without fractions.
Is it okay if you leave it as a decimal, or would you rather have it a fraction?
Either way is totally fine.
Okay, thank you.
And then this one, when you plug in 4 and -5, you get 4 minus 5b, plus 5b is equal to -8. And then you can solve for a and b. Okay, let's go on to 8.1, 71. I'm going to skip that one. 65. 65 is a great example. Make sure you know how to do this one. This is exactly like what we did in class yesterday. Come up with your own system that has either one solution, exactly one, no solutions, or infinitely many. So that's a really important one. 71 and 77. Okay. Yeah, I didn't show you guys how to do something using a graphing calculator. I think there's a way to do it on Desmos. So let me just share my my screen really quick. Let me just share. So let's just go to Desmos. Oops. That's not what I wanted to do. So you can do a lot of these different types of problems. Let me see here. Do I have a password? I don't even know. I need to log in. So yeah, if you do Desmos, you can plug in like 77, y equals minus. Just a show of hands, how many of you have used Desmos before? Oh, cool. So a bunch of you have. Okay, cool. Well, we're going to use it sometimes throughout the course. It's a really nice tool for visualization. But we didn't have to do 77. 73 we didn't have to do 71. Got it. Yeah, so just, you can type these into Desmos and it's nice. It'll give you the -3 point. So this is a negative 3.44 x minus 7.72. And then you can make another one, y equals 4.19 x minus 8.22. And then you can look for their intersection point, which will be, and I think it'll point it out for you, this one. Okay. So that's a nice thing you have access to if you ever need it. It's good for checking your homework as well. Okay, now stop this share. Are you sure? Off on iPad via AirPlay. Okay. Now let's move forward to. I'm going to skip to 8.2. Let me look at those problems. 8.2, number 73 and 79. So okay, let's do 73. So I'll do 73. So this is 8.2. .2, 73. And then I want to do a few problems continuing on setting up this dirt problems. Okay, so this one is x plus y. Was 73 assigned on this problem set?
Yeah,
8.2?
73 was assigned to 8.2, but not 8. No, yeah, just it was assigned. Never mind.
Okay, cool. So yeah, just if I'm ever doing a problem that wasn't assigned, please just stop me, and because I do that sometimes because I forgot like the rule that I gave, and sometimes students also get it mixed up. So x plus y, this one, and then x minus y over 2 plus x plus y. Okay, so this is one of these like complicated looking ones that looks a lot more intimidating than the ones that we had seen before. But can anyone suggest what we can do to really make this look a lot easier and make it look like something that we're comfortable with?
Just multiply by the numbers or the denominators on both sides.
Mm-hmm. Yeah, so for example, what would you multiply, like let's say this is equation A, it's equation B. What would you multiply equation A by on both sides?
2 and 5, or just 10, I guess.
Yeah, by the least common multiple. This way you get rid of the denominators and you just have x's and y's and you can group them together. So that's excellent. So we do, or you could even just do, if you wanted to, you could do get a common denominator and then cross multiply after. So it's totally up to you how you want to set it up. But if you just multiply everything by 10, what you find is, so I'm going to write it out, 10 times x plus y over 2 minus x minus y over 5 equals 10. And then you get here 5x plus 5y, because the 2 will cancel with the 10, minus 2 times x minus y is equal to 10. You could have gotten the same exact thing if you did a common denominator. Either way is totally fine. Now, being careful with the signs, this would be 3x minus 2 plus 2y plus 7y is equal to 10. So that's the first equation. So this is equation A. And it's still equation A. It hasn't even changed at all. We just multiplied it everything by 10 and combined like terms. Equation B, what should we multiply equation B by?
12.
By 12, but you can do even something a little bit smaller if you wanted to.
3.
Yeah, you can multiply everything through by 6, or get a common denominator and make it all over 6 if you want. So I'll do the other approach so you can see that as well. So you can make a common denominator. You can do x minus y. You can also do 12 as well. If you don't want to do least common multiple and you don't mind doing a slightly bigger arithmetic, like 12 is not really that much bigger. So that's totally fine as well. You can do this over 6, but it's got to be another 3 here. So 3x minus y all over 6 plus x plus y all over 6. This is equal to combining similar fractions, we get 4x minus 2y, because that's minus 3y plus y, all over 6 is equal to minus 2. And I'm going to multiply both sides by 6, so I'm going to just write a new equation. 4x minus 2y is equal to negative 12. And that would be the next equation I have. So that would be B. Let me get rid of the box. All right. And now I have okay, so the least common multiple is 12. You don't, if you combine fractions, you don't need to multiply, like when you're getting a common denominator. You're just changing, when you do a common denominator, you're only changing one of the terms. So you don't need to multiply on the other side. When you do a common denominator, you're just focusing on one side, and then you multiply that denominator to the other side. Okay, I'm going to erase these arrows because I think they look kind of messy. Are there any questions? So this is rewriting that equation, and then this one is the other equation, equation A and B. So this one and all right, now we can solve the system. Unfortunately, it doesn't. This is actually a good one for us to practice. We haven't done one like this where it's like something it's not immediately obvious, like what you can do to cancel out the variables. So anyone have any ideas what you can do to the red equation and the green equation to cancel out one of the one variable?
You can multiply both of them. You can multiply 1 by 2 and 1 by 7 to get y equals 14.
Excellent. So we haven't done that yet. So that's a really good observation. Sometimes you can't just, yeah, you can do the red, you can do either get rid of the x or the y. But let's say you want to get rid of the y. There's no nice number that like 2 multiplies by to get to 7 unless you do like 3.5. But you don't want to start working with fractions. But what you're allowed to do is you're allowed to multiply both of the equations and then cancel them out. So you don't just need to multiply one and cancel. You're allowed to do both. So let's do that together. We can multiply the first one by 2. That would be 6x plus 14y is equal to 20. And then the next one would be 4 times 7, which would be 28x minus 14y. And what's negative 12 times 7?
84.
Nice. So this would be negative 84. Putting them all together, going back to the black pen, this would be 34x is equal to negative 64. I'm not loving this answer. Let me just check it. Did anyone check if, anyone see any mistakes I might have made?
No, I got the same answer.
Oh, okay, thank you. Is that the correct answer in the back?
Yeah.
Okay, cool. And everyone knows, by the way, all the odd questions, the solutions are always in the back. Okay, so when I'm on our tests, if you get a weird fraction as an answer, that should be a sign that, hey, wait a second, like all the answers will probably be nice numbers. So if you get like negative 64 over 34, please ask me or double check your work. There's a chance that you made an arithmetic mistake somewhere. What would it simplify to? Yeah, I don't think it would be very nice. So x would equal to negative 64 over 34. And I really don't like it when you get fractions in systems of equations, because then you need to either solve for the other y by doing another elimination, or plug in a fraction into like an algebra equation, which just is, you know, kind of annoying. So this would be negative 32 over 17. So it's a fractional answer, and that's okay. And then you do something, you'd also plug this in and solve for y. Okay. Any questions? I'm not going to finish that one there, but probably instead of plugging it in, I would actually recommend doing what Archer suggested, is just do another round of elimination, multiply by 3 and 4, multiply the red box by 4, and maybe the green box by negative 3, and then eliminate the x and just get y that way. I think that would be easier than plugging in a fraction and doing arithmetic. Are there any questions on this example? And this is as hard as it gets for solving a 2x2 system where you don't have like a simple elimination right off the bat. So please hit yes if you're comfortable with this question and how we did the elimination, why we kind of first got rid of the weird looking stuff and made it into a standard form. And then once it was in standard form, how we used the coefficients and we multiplied both equations to get them to match up and then cancel. So please hit yes if you're comfortable with this one and ready to go on. Cool. Can I get maybe like, I want to get 12 yeses total, at least. And also some no's if anyone has any questions. Any questions here? Let's see. And just message me if you had any question. Okay. So I want to talk a little bit about some questions on 8 point. Yeah, I want to go through example 7, and this will really set you up over the weekend. I don't know when I assign these questions to be due, but I think I'll make it due like on Monday, so you have like a few days to work on them. It should only be after these 8.1, 8.2, 8.3. I think is only like 8 problems or so. But really think about them. Try to do them carefully, and have fun with them. I think they're really good word problems. Okay. So let's do example 7, section 8.3. Example 7. I have a student here asked about the set interval notation for 8.2 number 43. So let me just take a look at that real quick. So for 8.2 number 43, it happened to be, because they're the same line, it's just all the points that are on that line. So a fancy way of writing that is to use set interval notation. It's the set of points x, y, and then you put the bar for the condition. This is the condition, or it also means such that. This is the set of points such that they're on that line. So 12x This is 12x minus 6y equals minus 15. So that would be 8.2. Okay. So let's do example 7. So a Boeing 747 Boeing 747 flies 4 hours west with a 60 mile per hour tailwind. Returning against the wind takes 5 hours. Find the speed with no wind. Okay. Do you guys know about this effect? That if you fly from New York to California, it's like a lot less time than flying from California to New York. Do you guys know why that happens? What the wind is then?
It's the tailwinds because it's going west.
Yeah. They say it's there's like a jet stream in the atmosphere, and it pushes the wind is always blowing towards the toward west. And I think it might be because of the rotation or something. But yeah, it's easier to fly to California than it is to go back to New York, or go to New York. So okay, so let's. What would be a good approach for this? What method could we apply for this type of problem that we had seen before?
That table?
The table, right? This is a dirt problem because we have time, we have speed, and we have, in particular, we also have 2 trips. Now, it's not trains meeting each other or trains catching up or something like that. It's slightly different, but we can still think about it and try to figure out how to set up the table. Very good. So let's do trip 1 and trip 2. This is not looking good. Okay, so this is trip 1 and this is trip 2. And we have distance, rate, and time. Okay, let's plug in the easy stuff. So what do we know about, and this is a little bit tricky. What's something easy we can plug in right away? What are the easiest things to plug in?
60.
60 is true. We're going to talk about that in a second, but there's something easier a little
4 to
bit.
5 hours.
Yeah, we know there's no argument that the first one takes 4 hours. So that takes 4 hours. and the other one takes 5 hours. Okay. Now I'm hesitating on the rate because what is the real unknown in this problem?
How fast they're going on the second trip?
Okay, distances, we don't know the round trips, right? So that's an unknown. So let's do that first, okay? So we don't know anything about the distance. So the trip 1 travel distance d. Can we say anything about trip 2? Does it relate at all to the distance traveled in trip 1? Do we need to use a different, do we need to use a different letter here or different subscript? Do they have any connection? So what do we know? How does distance 1 relate to distance 2? Because we always want to be thinking, do I need to use another variable? What do you guys think? What's a key thing about this problem that allows us to maybe not have to write down distance 2? What can I write instead of D2? Is there anything simpler I can write?
Just D1 again because it's the same distance.
Awesome. Nice to know. So anytime you have a round trip problem and you're doing one of these dirt things, keep in mind if it's a round trip, you don't need to write a separate distance. It's going to be the same distance there as it is back. So that allows you to kind of simplify the problem and have less unknowns. So I'm just going to put a D1 here, but later we're just going to write it as distance. Okay, this is now a part of the problem where you need to think a little bit and understand some of the terminology. Do you guys know what it means to have a 60-mile-per-hour tailwind? Have any of you ever heard that term before? What does it mean? Lily, do you know? Or anyone want to volunteer to explain what tailwind means?
It's pushing you 60 miles per hour faster.
Yeah, exactly. What does a headwind mean?
It's taking you back that much.
Exactly. It's a lot like these problems are equivalent to like the if you've ever been gone whitewater rafting or canoeing in a river, you know the river has a current, and so if you're going with the current, you're going faster by the rate of the river, and if you're going against the current, it's kind of making it go slower. My favorite example for this is back in the day. Do you guys remember walking around a little bit in airports? Do you know how they have in some terminals? I don't know if they have it in San Diego, but in some parts they have like those long, flat treadmill things. So
those are so fun.
Right? Have you ever walked backwards on those? Like gone the other way that you're supposed to?
All the time.
Nice. So this is, if you think about that problem in that scenario, that's just exactly what's happening here. So what they're telling you is like the 60 miles per hour is the current or rate of the wind. Without any plane, the wind is just blowing at 60 miles per hour. And if you're going in the same direction, it's adding 60 miles to your speed. And if you're going slower, if you're going the opposite direction, it's taking that speed away from you. And you can really imagine yourself walking along that treadmill. If you're walking with the treadmill, you would walk faster than somebody who's walking next to you. And if you try to run against it, then somebody else going in that direction is going to be going faster because you got to keep up with the treadmill is moving against you. So we don't know the rate of the plane, and that's what we want to find, the speed with no wind. So let R equal the rate of the plane or the speed of the plane without wind. What can I plug in for the rate that the plane is traveling at for trip 1? What will be a nice expression there? You want to have a nice simple expression? If the plane generally goes like 400 miles per hour, what would be its rate on the trip where its actual like rate, not just like how fast it would move on its own, but with the wind? How would you come up with a nice expression for trip 1? What do you guys think? And you can message me also if you know the expression. What would it be? If R is the rate of the plane without the wind?
R plus 60 for the rate.
Perfect. Yeah, exactly. It's R plus 60. Because you're making it go faster because it has a tailwind. The wind is pushing along the tail. Now, if it's going backwards, what would if it's going back from the East Coast back to the West Coast, and it's got a headwind now, how fast will it be going?
R minus 60.
Awesome. And think about these logically. You see that the rate for the first one is higher. That means that the time should be lower. I've seen students mix these up a little bit, like they just kind of plug them in randomly. Make sure that there's some intuition, like the shorter trip should have a faster rate, and the longer trip, you're traveling slower. You're doing R minus 60. Okay, now we have our 2 equations, 2 unknowns, and we can set it up. So we have D equals R plus 60 times 4. And we also have D equals R minus 60 times 5. What approach would you guys like to do here? Elimination or substitution? Either one is fine. I think I would do substitution as well, just because like D equals, whenever you see something like that, just set them equal to each other. Like it's similar, it's basically elimination as well. But just plugging it in, you get R minus 60 times 5 equals R plus 60 times 4. This would be 5R minus 300 is equal to 4R plus 240. Adding 300 to both sides, I get, and subtracting R, I get R is equal to 540. Okay. So this would be 540 miles per hour. All right. So now you've basically seen all the main types of word problems you can encounter. You saw trains leaving a little bit later than each other. You have to set up the time for different expressions. This one is really nice. It's a current problem where your rates are different based on some current in the river, and if you're going in different directions, you got to do R plus 60 or R minus 60. But that's pretty much it for the types of problems to expect. There are sometimes different ways of thinking about this. Let me think here. So it's going plus 60. Minus Yeah, for 8.3, only do the problems that I wrote. Yeah, just I think it was like maybe like 8 problems or so. All right, so this is a good place to probably end for today. Do you guys have any questions about anything from this problem or any other ones? Okay, excellent. So next week we'll on Monday we can kind of go through. Please really take your time thinking about the homework. I'll make it due. I think I'll make it due like on Monday, but try to get it done as much as you can by the weekend. We'll go over it on Monday. I'm thinking to do a practice test on this on Thursday, and then the following Monday will be another exam. Maybe Tuesday, depending on how you guys feel on next Thursday. So next Thursday, I would like to do a in-class. Let me think about this. Yeah, next Tuesday, I will give you guys a practice test to do at home on Wednesday, and then we can go over it together on Thursday. And then this way, on next Monday, not next Monday, the Monday after next, you guys will be ready for another exam. Which will be really similar to these types of questions about these types of word problems with like the Mesa College students, the T problem, somebody traveling along a river back and forth, and a train problem. So no surprises, but you need to practice them to get comfortable with the setups. Okay. All right, guys. I hope you have a great weekend. Try to limit your screen time, and be present as much as you can. I struggle with that as well. All right, guys. Take care. Bye.